Oh, give us a moment, Jenkins. Oh, yeah, I had to walk. Car broke down. Yeah, that's not good. Yeah, I know Mrs. Tweed told me not to drive the car down the garden, but you know, it's better than walking. Hello, welcome to Tweed's Garage. In this video, we're sort of doing a side project to what we normally do. This is a sort of project that needs to be done because it sort of involves everyday transport. The story behind it is, if you saw Dean's channel, I was sort of heading over to Dean's to meet up with him with the aerial cranks, have a look at that, and he's got a Lambretta crank we were going to pull apart and see if the conrods would be a viable option to use on the aerial leader cranks assembly, and whether we could, you know, build up new cranks with Lambretta conrods. So that was the plan behind that. Anyway, got about halfway there in the mighty Micra, and all was going well, and stopped at a roundabout, went to pull away, funny sort of noise, bit of a bang, and then sort of rattly, rotating, transmissional noises coming from the front, but no actual forward motion and no back motion, and just sat there on the outside lane of the roundabout. So yeah, put my hazards on, started to push it aside, and of course everybody overtakes you on the inside where you want to push the car to, because that's what people do nowadays. But eventually managed to get it off of the roundabout, and then a nice young lad in a flashy BMW, you know, all tricked out, obviously a car man, he stopped, gave me a hand, pushed it off of the main road so it was out of the way. So I had a little look round it, and had a look underneath it. There was no oil underneath it, no transmission fluid, you know, there was no drive shafts hanging down. So I suspected, being a CVT gearbox, you know, sort of opinion is that, oh, they're a disaster and they, you know, they explode and fall apart. But the car's done like 120,000 miles, so I thought, well, you know, it's getting on a bit. It's 23 years old, possibly, and it sort of sounded like maybe the CVT belt had let go, or sort of flex plate had cracked, sheared, something like that, and things were rotating, but there was no drive getting through to the wheels. So anyway, on further investigation, once got it back to terra firma where we could sort of pull it apart and have a look at it, we discovered that the one of the half shafts had broken. Yeah, you know, the power of the mighty Micra literally sheared the drive shaft in half. And I got it on the bench here, and I'll show you what problem we've got. Well, we wouldn't normally have a problem, but this is the annoying thing. Spent ages looking on the internet and Nissan part numbers, found the part number for it, and it is now obsolete. They don't do it, they don't stock it, nobody stocks it. The only chance you've got is getting a second-hand one. Had a search, you know, it searches like 150 breakers yards, you know, a few days on the trot, keep trying. No luck. I think brother-in-law found one in Germany, they didn't want to send it, and you know, when you look at it, it's like, well, is that going to have the same problem as this one? You just don't know. So in reality, that's the end of it. That's the end of the mighty Micra. You can't get a bit for it, so you have to scrap it, you know. And government and motor manufacturers, you know, that's what they want you to do. They don't want you rattling around in old cars. But we're going to stick it to the man. I've got a plan. We're going to try and fix it. It'll probably set the internet alight. Armchair warriors will be furious, engineers, all that kind of thing. But it does a few thousand miles a year. It's like the glorified shopping cart, and better to fix it and use it and save the planet that way than scrap it, get somebody to build a new car and go and buy that. Yeah, no sense in it. So down to the bench. So here it is. Here's the broken one. Now, I thought this morning I had a bit of luck. I sort of asked ChatGTP, you know, gave it the part number and told it to go and have a look and see if there's an alternative. It did come up with an alternative one. It was the right length. I think the splines on this end were good, but the splines on this end weren't. I think there's more splines on this one than the one that I could get from German and Swedish at a reasonable price. It was about, you know, I think it's on special offer about 55 quid, something like that. But Of course, it's not made by the company that originally made these. I don't suppose Nissan made these by any stretch of the imagination. There is a manufacturer's make on it somewhere, CKN, but whether that's just these bearing housings, you know, rather than the whole shaft, I don't know. But if I whip the rag away, you can see the well, you can't see the damage because I've taped it up, so you couldn't see it. But yeah, let's get this tape off and show you. I reckon the tape repair would probably stand for a little while. You know, it doesn't pump out oodles of power. So here we go. Here's the brake in the middle. Now, the bit that is missing off of this drive shaft, we have got it. It had a rubber dampener on the drive shaft here. Now, allegedly that is to reduce vibrations and to limit the possibility of fatigue on the shaft and the you know, the bearings and that kind of thing. But it was that rubber damper that actually caused the drive shaft to fail. So it did no good at all. You can see here that this is I think it's 20 millimeters originally. Yeah, 20 millimeters. And where the damper was, it's sort of wasted down to, I can't get it accurately because it's sort of broken, but get a rough idea. Yeah, 17, under 17, like sort of 3 millimeters of material worn away in the middle. Whether it's where it's just been flapping around because one of the fixings was missing, but water's got into it, and whether just that flapping about has just eroded it away to the point that it eventually started to crack. But it's been going on for years, because you can see here, if I show you the brake, this is the latest brake here, but you can see all round here and the colour of it, that's been broken for a long time round there. So this shaft's sort of been, this guy's been running on a drive shaft that's sort of about 10 millimeters, being generous, and then it's just cried enough and sheared off when I pulled away. You can see there again, see on this side, see old brake there, you know, obviously broken a long time, broken there, started to crack there, and then eventually gave away along that face there. So quite remarkable. We're not going to be beaten, it's going to be a messy job, but I've got a bit of some people throw their arms up in the air and in horror, but I've got some bright mild steel, slightly bigger bit of it there, and the plan is, I've filed this is not very hard at all. It's got splines at the end, it'll be hardened on the splines, but not in the middle here. So the plan is, you know, and this is going to be better than 10 millimeters of rusty metal to keep it going. So the plan is to try and strip this down, get these spline end shafts out of each side. I'm not sure whether it needs to be lined up like a rear prop shaft, because if one's a constant velocity joint, well, they're both constant velocity joints, don't they? They sort of work slightly different to a universal joint. Yeah, and then the plan is to sort of turn this bit down to a shouldered nub as a technical term, and then the same here, maybe longer this side, because maybe the torque happens more this end. Let's try and retain as much of this as possible, and then this shaft here, drill and bore it out so it's a push fit it onto in between these two pieces to get to the right length, and then weld them up top and bottom. That's the plan anyway. It'll be fun and it'll keep it on the road for another couple of years. So managed to get some of the goop out of the way so we can see what we're doing. There is a circlip here. I suspect there's one on the other side as well, which will allow me to pull this shaft out of this assembly, but this needs to come out. There might be a spring clip on it. But it's been yanked on before. That shouldn't be like that. That's been dented back. I think the best thing is to try and knock this, get swaged over a little bit, try and knock this retaining ring off to get this assembly out and have a look. It might be like the drive shafts are sort of retained in the gearbox. There's a ring, split ring that goes on there to stop it coming out. Yeah, we need to see. We can get that off. We can peen it back over afterwards. I think it's just to stop it falling apart when you got it off of the car. There we go. And that will come out. I want to try and mark it somehow so it goes back in the same way. Okay, yeah, it's getting stickier as we go, but I've managed to get it apart. I've sort of blued it up, so hopefully in the rag, so I know which ball goes where, I'll just leave that like that, ready for reassembly, and then this drops through that out the back without having to take this sort of spider off of there. And I think there is enough clearance on my lathe chuck to pop this in beyond the jaws, and then clamp down on this part of the shaft here. That's the plan. I'm going to give that a go. Okay, you can stop shouting at the TV. I suddenly realised you could knock these out. So because I couldn't get this one apart, I thought there must be a way of getting the shaft out. So I boshed it with a copper mallet. I was holding the shaft in the vise and it come undone. It's got these little spring clip retainers that keep them in position, like the there's one that goes on here that keeps this end of the drive shaft in the differential housing. Yeah, so knocked that end off, knocked the spider off of that end and put it together and pop my greasy balls back in the pot so they don't get fluffy. I managed to beat that flange back down into sort of, a bit of a better shape. I think it had been dented when trying to get out of the gearbox. There wasn't as much leverage. I think it got pulled against the side there. So you straighten that out so that can be clicked back on, as long as I can pop that in. I don't have to pop it back out again to knock it on. Yeah, so we've got much more clearance to work on this, and been measuring, and it's 15 centimetres between this shoulder and that shoulder there. But I think what I'll do, because the brake's not in the middle, it's more to this side. I want a bit of meat to go into my new bar. I think what we might do is go to this shoulder and machine this little lip onto the new shaft when we've welded it on, because there's only the gaiter that goes around this piece here, so as long as that's down to dimensions and got a shoulder on each side of it, that should be fine. And this end, it's okay up this end. There's not any corrosion gone beyond this sort of shoulder point here. So I think what we might do is go from that point here to that point there. I mean, these joints move in and out, so there's a little bit of leeway if we don't get it exactly right. But measuring from there to there, it's 16.5 centimetres. So I think that'll be our start and finish point. We'll make our shaft 16.5 centimetres. So that when we push it all back together, it should all be the same length once I machine down to these shoulders there and there. Yeah, so it's just deciding which way to do it first. I think I'll turn the shaft up first and then drill and ream the holes each end so I know they're an accurate size. Then when I turn these down, I can turn them down so they're sort of a couple of thou over so that they're a push fit into the ends, and hopefully just pop them in the press and yeah, give them a nice lead-in chamfer, pop them in. That should be good. So we'll crack on with getting this sorted out. I think we'll start with this. So we pop the bar stock into the lathe and then just face off the end. We don't need to do it all the way because we're going to centre drill it. Then centre drill it, ready for our centre. And we're turning the stock down later. With the hole centre drilled, put in a parting tool and part the stock off to length. Going nearly all the way through the material, but just leaving enough so it still turns, but thin enough that once we stop the lathe and remove the centre, you can just fatigue it off. Like so. Then turn the stock over, pop it in the chuck and just face it off on the back. And again, centre drill this end. And turn the outside diameter down slightly, just to create a shoulder to grip it in the 3-jaw chuck. With the shoulder turned on it, we can put that in the 3-jaw chuck and the live centre in the other, and turn the bar down just enough to clean it up. Matching the other turned end quite well, just leaving this little ring to pop off the end. Now I need to pre-drill the end, and this is for the spigots on the broken bits of drive shaft to be pushed into. And I'm doing these first because I'm using a milling cutter to get them nice and square at the bottom of the hole, so we hopefully don't get any binding up. And with one end done, just go in with a round nose tool just to turn in a relief that I can build up weld when welding it onto the other piece of the drive shaft. And flip it over and do the other end as well, which, as you can see, we've used the milling cutter to bore the hole in this end too. So that's the bar, all the turning done. So now we need to turn our attention to the broken ends of the drive shaft. So again, part these off to finish length. So I've allowed for enough to turn up a stub on the end of each half of the shaft, which will then be pressed into the new bar that we just turned up. And just proceed to machine this down to an interference fit into those holes that we milled in the bar stock. Before moving this to the press, I just ran a chamfer on the end of the shaft. With the stub shaft turned down, not seen here, but I just turned a little chamfer on the end to help when pressing it into the new shaft. There we go. Press away, interference fit. All goes on very smoothly. About 4.5, 5 tons of pressure. And there we go, one stub pressed in. Now we need to turn the other one down. Same process again, parted off to length and turned down to an interference fit. And just check with the micrometer as we go. Try not to miss our target. Finish off with a chamfer on the end. just to help it lead in when we put it on the press. Watch out for this end, just for a bit of clearance for the weld. Right, off to the press. Now this side went okay, but I was running out of height clearance in the throat of the press, and I had it all drop down onto the bottom frame, and yeah, I was a bit over generous with my interference fit. I was nearly maxing out the press to about 9 tons, 9.5 tons. Managed to get it on there. Just a little gap, small gap, under 0.5 mil, which is quite annoying. But as you can see the bottom of the press distorting, which will need to be straightened and strengthened up a bit. So here is the drive shaft all pressed back together. All went well, this went nicely. Couldn't close this gap up here, so a bit of personal pride there that I don't know whether I sort of left this shaft a little bit long, or the shoulder, or it bottomed out on something, but I couldn't get it any further than that. And it's fairly straight, it's not too bad. I've been clocking it and then sort of pressing it. It seems to be worse at this end than this end. But these are difficult to hold, you know, find any sort of flat surface to hold these on, quite tricky, but it's not too bad, it's not horrendous. So there's a bit of wobble there, but not too bad, and I wouldn't be surprised that when I weld this there'll be a bit of distortion on the shaft anyway, so I'm sort of going to weld it. What I'll do is I'll clock it where the high spots are, and then put a spot weld on there, and the same on this side. That'll hopefully sort of, you know, pull it in a little bit, and then weld them both up. But I haven't finished machining this down. It's a little bit undersized because it's all right this side. This side I need another little lip there. It should be there for the CV boot to sit into. But yeah, we've got to come down anyway, so there'll still be a lip there, and then reduce this down a bit to this size as well. So that'll be true between the centres when we've done all that. So the only wiggle then will be sort of round here. So I think we'll be all right. I wasn't convinced how straight it was before I sort of took it. I know it's broken, but yeah, I wasn't convinced how straight the ends were anyway. But good progress. So all I've got to do now is weld it up. I'm going to weld it on the lathe. I know there'll be shock horror welded on the lathe, causing damage. I'll demonstrate to you. I think we can knock this down to 22 is the slowest. I reckon MIG on there, that should go quite nice. But what I'm going to do is on the centre at this end, because I'm only revolving it, I'm not turning it at the moment. I'll put some insulation on this side, and I'll run a dead centre on this side, and the dead centre I will put insulation tape, just wrap insulation tape round on the taper here and pop it in the headstock. So then with that going in there, I can put my clamp on this bit of the steady to get my earthing going through the shaft, but then hopefully it should be totally insulated from the rest of the lathe. and then weld those up. I'll put a fire blanket around to stop any sparks causing any damage. Okay, so prepping for welding. I've put insulation tape on my dead centre this end, and then on this end I've put insulation tape on that so it's not touching any metal on the rest of the tailstock. Hopefully it will insulate all the welding goodness within the drive shaft. So that's the plan. Got a fire blanket down so we don't damage the ways, and then there's a bit of cover here for the tailstock so we don't get any sort of stray spatter causing any problems. And yeah, clamp on there because it makes a better connection for the welding clamp. So we just got to put the drive shaft on and weld it up. See how this goes. So we just want it tight enough so that it turns. First time it stopped moving. Second time with a drive dog, it was too fast. So third time, just turned it by hand, and that worked perfectly. So now I'm just drilling out a piece of steel stock to act as a split ring to grab the end of the splines on the shaft, just on the very end, because you couldn't line the spline pattern up with the 3 jaws. It was always falling between a couple of splines on one tooth and sitting on another spline on another tooth. So doing it this way was an easy way to get it to run true. So just bored it out with this 24mm drill all the way through. And then cleaned it up and bored it out to size with a boring bar. Apologies for the squeak. And then turn a chamfer on it just to make it easier to locate the drive shaft. And that's all the turning done. And then just cut a slot in it just with the angle grinder. Doesn't have to be deadly accurate, just enough to split it. When you put it between the jaws on the 3 jaw like this, it will close up as you tighten it up, gripping the drive shaft. And running pretty true. And then with the other end on the live centre, just proceeded to hog off the material to get the shaft down to size and to create the shoulders for the CV boots at each end. Then check the size as we go and carry on till we're done. And then just to finish off, I use the round nose insert just to create a round fillet on all the edges I left, so not to create sharp edges for possible stress points. And with all the turning done, I just went over it with the finger sander and with cloth of different grades, just to clean up all the any rough edges and smooth it out as best as possible. And then just apply a coat of paint. Easiest just to do it on the lathe where it is. Yes, we did mask everything off. And as it's chilly, just help it along with a heat gun. So it's back over the bench, and pop this retaining ring back on, just a case of gently tapping it on, springing it back on over the lip. And then just peen the edge back over the lip where it got distorted, where I sort of eased it off with a chisel. And then pop in the repaired drive shaft, line up the splines, make sure the spring ring's located in the taper, making sure the spring's located in the chamfer, and then knock it home. Make sure it's locked in, and then slide down the boot, and set it home over the ridge at each end, ready for its clips to go on. And pop on the boot for the other end. Yeah, don't forget this, otherwise you have to drop the joint off again. I didn't actually forget this time. And then pop the other joint on and tap it home. And with it all reassembled, just take these securing clips, you just sort of trim them down so you haven't got too much overhang. And then get the three little teeth to go as far up and drop in as you can squeeze them, and then just tighten them up with the pliers. They're okay, they were stainless steel, so they're quite hard to bend. The pliers could have done with the handles being about another 2 inches longer for a bit more leverage. But with a bit of fiddling, we got it done. Where it got squeezed up, I just sort of knocked it down a little bit so it wasn't so prominent sticking out. And there we go, all done, sealed up. Just wipe the grease off. Oh, there was a lot of grease. Looks good. So there you go, drive shaft assembly back together, and yeah, all grease contained within the secured boots. One end of the assembly attached to the other. Drive transmitted quite nicely. Feels solid. you know, but we need to put it back on the car, see if it works, see if it restores forward motion to the mighty Micra. Yeah, so we'll do that. What's that, Jenkins? Car's not there. Oh yeah, car's not there. So it won't be in this video, it'll have to be in the next video. So, hope you liked the video. If you liked it, give us a little like, hit subscribe, and we'll see you in the next video. All right. What's that, Jenkins? Yeah, it's what they call a cliffhanger. Yeah, all we need to do now. So there you go. One drive fast. To do now is see if we've got. It's home time. Yes, I was filming. What do you want?